Just let me know when to start.
Yeah, you good to go.
Okay. Hi, everyone. Thank you for attending this. Today, I wanted to talk a little bit about introduction to function calling with Gemini uh, using Vertex AI and without using Vertex AI. So, little bit introduction about myself. That's me. That's my friend. I'm very happy with him. I'm a Google developer expert in AI and ML, also a cloud champions innovator, and also recently became a cloud research innovator. Uh, on the professional side, I'm still a student. I'm a PhD student. I work with University of Houston's I2C lab and Rice University's Habanero lab. So essentially, I work in the intersection of security and privacy, which now includes AI model safety. So the things we want to cover today. So first, what is Gemini? A little bit about Gemini, and then we go into some of the use cases where we might or might not want to use a LLM. Then we go into function calling, like what is function calling, why we might want to learn about it, and then how do we learn? So the developer resources, and then a little bit of Q&A. We will go into codes. I have a couple of Google Colabs prepared, which you can play with. And I'll be happy if you actually run the collabs with me together so we can also kind of troubleshoot if you have any questions or problems. Please-
Rabimba, very quickly,
yeah.
we got a question here.
Okay.
Oh, never mind. Back to you, Rabimba.
Okay. So actually, feel free to like interrupt me anytime if you have a question. But Madhusha probably will have to jump in because I cannot see the Q&A screen. Okay, so little bit about Gemini. I guess if you have attended yesterday's session, you have already seen this, and I kind of expect a little bit of you already know about LLMs and played with it. So maybe just a little bit of reaction. How many of you have played with Gemini or any kind of generative AI or any kind of GPTs? Awesome. Okay, so what is Gemini? Gemini is one of the new models from Google. It's state of the art. It has multimodal reasoning. What does it mean and what we can do with it? I'll go a very little bit into that. It's a highly optimized model, and it still have options of actually running in different plethora of devices so that it gives users kind of choice of running it between portability and performance and running huge amount of data. And one of the core things Gemini has is that it is built with responsibility and safety in the core. What does it mean is that every response you get certain kind of safety guarantees and certain kind of markers, which helps you to have your own guardrails, or which allows you to have your own kind of interaction guidance, so that the app you built doesn't suddenly come into the front page of Hacker News for content it should not have produced. So looking into more other things inside Vertex AI and what you can do. So we have right now Gemini 1.0, which is kind of the publicly available high performance model. And there is also Gemini 1.5, which is available to certain private testers, and you can also play with it. With that, you also have Gemini 1.0 Ultra, which is the most capable model for most highly complex tasks. For what task you choose what, we will go a very little into that after a while. Apart from that, in the model garden in Vertex AI, you have a plethora of other models. For example, the open source ones like Gemma's 2B and 7B, Palm, Imagen, Chirp, Cody, and then Mistral from Mistral AI, and Meta's Llama models, and a lot of Hugging Face models. The topic we want to go to today, function calling, is not supported by all of the models. Function calling is something of a schema of kind of like a It's not a standard, but it is a schema which OpenAI came up with, and a lot of the other models also support it right now. So you might want to kind of like see the supports of those models before you can implement it. For example, Gemma, even the 2 or 7B, does not right now out of the box support function calling. So you might not want to implement same kind of things inside that. Also, certain aspects of function calling is not available to all of the models. We will go into what that means after a while. Talking about Gemini 1.5, the the biggest thing we need to kind of keep in mind while building applications with any of these models is that it has a huge token length, it has a huge context window. What does it mean is that you can have a single prompt with huge amount of data passed into the model, and that huge amount of data gets to the model as a context. Based on that, it can answer your data, questions or answers. That is a huge benefit because previously we used to do a lot of other plumbing to actually have this kind of context, and that's never as good as actually having a context window this big. But this is also highly expensive to run, and you might not want to run it for most of your applications, apart from the fact that it's in private preview. But you can get into a wait list and eventually you will get access to it. You can play with it, but I would be a little bit cautious about what kind of use case you want it to be used for. Now, coming back to Vertex AI, this is in Google Cloud Platform. We have a single one-stop shop where you can have all kind of different AI models, AI solutions, MLOps available for you to use. Today, we mostly will be talking about very specific things inside the AI platform, not that much into Model Garden and not too much of the other parts, not the solutions, not the other parts. Out of this AI platform, I want you to concentrate a little bit on the first thing, the extensions. Why? Even though we are not going to talk about it, that is important to understand the context of how function calling or what function calling does and how it was being done before function calling was implemented. If you want to try Gemini today, so you can try it, the multimodal experience from Vertex AI. You can go into any one of them, and this is like sample screenshot from them. You can pick and choose any one of them, and you can play with it. If you are interested, I can actually show it just by a screen share that okay how it looks. But we'll play with that after we do a little bit of function calling and like see how that can help us even in these scenarios. Vertex AI is built for developers in mind. What it means is that it has easy integration with a lot of the ML tooling platforms, for example, LangChain, Llama Index, and data vector databases like Pinecone. These has kind of like first class citizen support with a lot of the things we have in Vertex AI. Vertex AI also allows you to automatically kind of immediately run a whole Collab enterprise notebook or even a Vertex AI workbench, which essentially is a very souped up Collab, which will be able to run most of your like demos we will see today and the ones if you want to build something on top of that. Now, coming into the use cases for general AI. So we have three parts. One is predictive AI, generative AI, and the multimodal generative AI. For the prediction, it's essentially what we used to do for using normal machine learning models before, traditional machine learning models before. So regression and classification, sentiment analysis, object detection, those kind of specific classification, tasks. In generative AI, as the name suggests, we are generating new information or rather synthesizing information. So what do we synthesize normally? It's text and image and code generation. Code generation is a huge part of it. Then rewriting text. So summarizing, rewriting, generating new text. And then also do kind of like generate descriptions, generate question and answers based out of a huge corpora of text. take these exact same capabilities and think about how what you can do with different modalities. By different modalities, here we are specifically talking about image and video. When I say video, we specifically want to clear out not all models are capable of all aspects of a video. So whenever we think of a video, what do we think? It's a sequence of images with audio. Most of these models do not have inbuilt capability of kind of like understanding your audio. So for example, if you have Gemini uh, Vision or even Gemini 1.5, it can understand video, but it will not understand the audio alongside it. So if you are building an application which it's important to have audio as well as a video, maybe you want to transcribe the audio and then pass it along with the image or the video or the snippets for the model to understand. Other than that, everything that comes with this portion of the domain is image and video, is that then we start asking questions on video. Okay, what does that video do? What is being discussed in this video? Okay, do you have anybody talking about this specific topic in a video? These are kind of like video understanding, question answering based on what has been happening. Then there are other parts of it. For example, spatial reasoning and logic, which essentially means in this video, am I raising my hand? Did I raise my hand ever in my video? Did I change my stance? Is there a mouse on right side of me? Am I drinking coffee while talking? These are kind of reasoning and understanding from the video that we can have. So these are all different parts of the multimodal generative AI and what you can do. Now you will see a small part uh, behind the slide where it's written RAG, function calling, extension grounding, pointing. Okay, that's a typo. The safety features. So we will specifically talk about function calling today, but we also, I just wanted to talk a little bit about extension grounding, is that where you ground your knowledge so that it does not just start inventing things for you when you are doing any one of these scenarios. So first, let's see how you can have access to the API. I have been talking about Gemini API, but all of it doesn't make any sense if you cannot play with it. And I wanted this session to be more like hands-on, go along with me kind of session. So let's start with getting an API key to actually work with the codes we will be seeing today. Let's have a kind of raise of hand. How many of you have played with AI Studio or any of the Vertex AI notebooks? Okay, I hope a lot of people. Hence, once we have our AI Studio, if you go to AI Studio, you will be able to go here. You will see what model you are using. So on the right side, you have the option selected to choose your model, which models are available in your account. Based on that, you will be given a kind of like template question answering system where you can just play with those models and you can just ask questions and get answers from that. You can also, once you write something, if you want to just get a boilerplate code, which automatically just works as long as you have an API key, you can press that get code button and it will create a code for you. So though this is kind of like how it will look like. It will give you kind of a boilerplate code where you just copy and paste it or just open it in a collab. And as long as you give it an API key, it should just work. Now, how do you get an API key? So on the left side, you will see something like this, get API key. You press on that and you will be automatically generated an API key. Most of the calls you can do are already, most of the languages are already supported for this call. So Python, Node.js, Swift, Java, they're all supported and you will get boilerplate code for all of them to work with it. So before we go forward, let's just maybe raise a hand or a reaction. Have most of you have the API key or have been already have API key or something? Because next I want you to kind of like start exploring this with me, and you will need the API key for that. I see some sad smileys.
Anybody having trouble accessing the API key? Hi, if you're from Canada, sorry. We just have to wait for a little longer, but the rest of you who got the chance.
Yeah, the easiest way would be, as mentioned in the chat, go to the Maker Suite or AI Studio, which is kind of the same. AI Studio is formerly known as Maker Suite. The other option, if you're, let's say, in Canada where the AI Studio is not available, you can go to Google Cloud and create a cloud project. And in the cloud, you can kind of, through Vertex AI, you can generate an API key, and you can still kind of do stuff there, but it requires some extra steps.
Yeah, we will actually go through that as well. But since I saw a lot of people yesterday saying that they don't want to use Vertex AI, so today I am going for both. How you can use both API keys to do that. So I have retrofitted some of the examples available. So maybe if you don't want to create a Vertex AI application, you maybe want to kind of like clone my notebooks, but you're free to use both.
Yeah, Alan is saying that, yeah, but you cannot use the API from Canada either. I think,
You
let's,
can, but I'm in record, so let's chat later.
yeah. Oh, just 1 second. I think to clarify this, you cannot use directly, as in AI Studio, or as you would use in, I don't know, other regions where the Gemini is available. You just create a key and you can call the Gemini API. But correct me if I'm wrong, in Canada, you're able to go to Vertex and deploy the custom model, not a custom, but I mean, through the model garden, you can choose the model, deploy it in Vertex AI, and then you can use it. Am I wrong in this? Can anyone from Canada verify? So,
No, that's correct. That's correct. You can do it that way.
yes, as I said, doable, but requires some extra steps. Sorry for interrupting.
So I'll go forward. So mostly we have been talking about how you can do it from AI Studio. If you ever want to kind of move to Vertex AI, there are available docs to how to migrate to cloud, or by cloud, I mean kind of migrate to Google Cloud Platform using Vertex AI. Now starting with function calling. Before we kind of start, I want you to kind of play with a demo. The link is available here. I also have it running, but so everyone can click this link. Oh, you cannot click the link. Okay, let me just copy paste it in chat. And I'll share this tab instead. Okay, so this is, before we go into like what is function calling, I just wanted to show a demo what it can do. So what we are doing here is that we are talking with a BigQuery dataset. That can be anything, any BigQuery dataset, or anything you want to have in your database. And we want to kind of like ask it specific questions and get answers. So for example, I'll try the same question I had in example. So why this question? This is right now running in a BigQuery dataset, which is on a kind of like a e-commerce data. It just shows that, okay, what has been ordered, how many has been ordered, and that. So once I run it, so we will see it immediately tries to run a certain, some function calls. What it means, we'll go back to that. So once it does the function calls, it returns us two things. One is the result, that, okay, how many percentage of orders are returned, and because that is in the table in BigQuery, and how it went to that answer is this query. So this is one small example of what we can do, how it was done. Now let's go back to our presentation. We'll understand what is function calling. We will go into the code and go through this code, how you can deploy it, how you can play with it, and also kind of also change the data set to something you want. So this is the same thing. I wanted you all to play with it or run it so that you can actually see what function calls are being invoked and what actually brings you to that result. Okay, why function calling? So function calling gives you very specific information. It extracts information from text and use that information to create certain other tasks. For example, calendar. It can translate commands. It can give you very specific answers in a very specific format. For example, in a JSON format or in a very specific SQL format. So in short, what function calling does is use certain tools. These tools work for you and then gives it back very specific instructions which the LLM can utilize to build a specific kind of data structure that you might want to use. Can we do it without function calling? Yes. Will it be as efficient? We will see very soon in a, like if we want to right now implement it, what happens. So this is kind of a sequence of interactions of what happens when we do function calling. So first the user sends a prompt and then it goes to the application. Just okay. Yeah, it goes to the application and that application actually goes to the specific model and the model actually gives it back specific information. What you do is essentially you describe external functions to the model. These external functions become your tool. These tools, if you use Vertex AI, some of these tools are inbuilt in the library you are going to use. But if you use Maker Suite or AI Studio, you probably have to describe those functions or actually write the code what you want it to do. And now those functions may be invoked by the model to get query. What kind of query? Let's look at some of the examples. So let me try sharing this tab. So this is all, refresh. Yes, this is mostly all of the things we will be talking about today. And you can just check this repository. You can just start with it and you can play with it. So let me start with this, this collab. So just go here, open in collab, and you all can see my. Yeah.
Rabimba, did you share a link to that repo?
Yes. So if you go to function calling, oh, okay, it's in the slide. So I should probably share also in chat.
Yeah, put it in the chat so everybody can quickly, at least they can bookmark it right away.
Yeah.
Thank you.
Okay. So this one, you will not need to use Vertex AI. There are pros and cons of using this approach. This is only for today's session so that you can actually play with it, even if you don't want to go into Vertex AI to provision or worried about cost and other stuff, or if you want to just run it for your own audience, this is going to be very useful. But not everything is going to be available. I'll talk about that later. So first, let us see what we have to do. So this is very standard. We are just installing the Google Generative AI library. And then we are gonna install the necessary packages. So for this, it's very standard. Now, what you need to do is that the API key you get from Maker Suite, you set it up. So there's a very nifty option here called secrets. If you press on secret, you can specify a Google API key where you can put your Maker Suite key and it will work. So even if somebody actually opens up your collab, they should still be able to use their own key and not your key and run it. So, okay, let me see if I have it. Okay, it has access now. Let's try. So, okay, now we are going to build our functions. So we are going to build our very simple function called multiply. So what it does is kind of just do a very simple multiplication, and it returns like a multiplication of a into b. We all know the strengths of the LLMs. Anybody want to volunteer some of the weakness of almost all the LLMs? So if you see, one of the biggest weakness of almost all the LLMs available today is mathematics, kind of like mathematical reasoning, but even more than reasoning, just doing simple calculations. But we don't need LLMs to do calculations for us, right? We can do some simple calculators. We can define our calculators. We can do very simple calculations just using our Python code to do that. This is exactly that. We have a small Python function which returns you like whenever you have something called to multiply, it returns you a multiplication answer. So we just define a function which does multiplication, which is this function, and then we just define our model. This has nothing to do with this. This is separate, and we just define our model. And we pass a tool called multiply. So let's run it. And we have it. Now, one of the recommended ways to run this is through the chat interface. So we'll start that. Now, there are different modalities of to do that. We'll cover that in more involved demos using Vertex AI. So let's start the chat. I run it, and we get all of these. If you see, there are two things I have not configured, but we get out of it, which is the generation config and the safety settings. So if you want to do more things, for example, if you want to add your temperatures to what you want your model to do, the creativity or those things, you can define all of them in the generation config. If you want your model to have safety settings available, which is essentially which will have that, okay, how much is the toxicity content, harmfulness content, you can define all of that here. I did not do that. Then we try to do a very simple mathematical calculation. So I have 57 cats, each owns 44 mittens. How many mittens is in that total? So we have total numbers of mittens 2508. And if we just do normal calculation, we check and it is the same thing. So what happens here is that it's actually using the multiply function we used to pass those methods and get the like result back and add it without it trying to guess what the answer is. If you have attended Henry's session yesterday, you will know how most of these LLMs work is trying to predict specific tokens. Prediction is not calculation, but we don't need to depend on prediction or try to predict the right calculations, right? We can just use a calculator which we defined and get the result out, and we can do the predictions for other stuff. For example, writing this sentence or things like that. Now, if we want to look at how this, like how we get this result, we can look at the chat history. We can get the functions to do that. So if I run it, if I go through it, so this is what happens. I have 57 cats, each owns 44 mittens. How many mittens in that total? So the model does a function call with name multiply. Arguments are 57 and 44. These are our A and B, which goes to our function here, and it returns A into B, which we get function response, multiply response is result is 2508.00, and the model gets that and returns that as a text. So in general, how it works for state diagram is that you start, you do a query, it goes to the model sees that is there something I can call. If there's something I need to call a function, it might or might not go there. It calls the function, it goes back and goes back to the user, and you get the result. So till now, anybody has any questions on that? Okay, yeah, Glenn.
We get a question from Glenn. Yeah.
What if you have multiple functions? Um, and what if you don't call it multiply? What if you have like a multiply function, but you called it subtraction? Will that confuse it?
It will. And not only that, I'm super happy that you asked this question, because otherwise I would have asked you one. Is that okay? Does it mean that it will work every time? So I'm not completely sure. I mean, as long as I've tried to benchmark in Gemini, it did work for me every time. But as I said, function calling was a concept made by, like, it was introduced from by OpenAI. And if you see a lot of open issues in different kind of like open source implementers forums, you will see that a lot of people kind of complain that, okay, I have defined everything and it still is not working. It's not calling the function. So that's where we want to ground some of these. So we want to ground what multiply means, when it will call those. And other than that, it might even hallucinate and without not even by calling these functions. I have not seen that in Gemini, but I'm not like, I cannot guarantee that it will always work. But if you do a different way, it will go in a different way, because it's based on the description. And the better you describe, the better you have a context of what it should call, it is supposed to work. I'm okay.
Sorry, I just wanted. Sorry to interrupt.
Yeah.
So that's one. So that's going to be something that people might have to watch out for if they're getting, I don't know, like models from other people. Like I mean, somebody could technically put in specific functions that might give a certain false answer, or to trick the user into doing something, right?
Exactly. And hence, this is why I was telling that, okay, if you want to play with it, MakerSuite is fine, but maybe you want to use Vertex AI for if you want to productionize it or use certain tools, because so here Peep installed the generative AI library, which is for the AI Studio. The one that comes with Vertex AI, that has some of these tools inbuilt. So we don't actually define these functions. A lot of these tools are built here. We just point it to that, and it kind of can work with some of these. So that raises, like, that mitigates it to certain strength. But yes, if you are doing it, you have to be very careful of how you are defining these functions and do that. So if you keep on playing with the SQL talk with BigQuery, you will see it works a lot of times, but sometimes even after a function calling, it will just say that it cannot do certain stuff. Yeah, I think we have another question.
Yeah, this is Ali. So really, it's a probabilistic chance that the LLM is going to pick your function based on the function name, and maybe you can help the LLM discover the correct use of the function by a description that you put in. Is that correct?
Yes.
Now where would the description go that would help the model pick that this is the right function in this context?
So most of these are already used for training. That's why when I said that Gemma doesn't have the function calling capabilities, because it was not part of it. It was not part of the initial training. So these descriptions, these are already trained in those models, in a lot of them.
So is there a list of functions that you could define as a user? I'm trying to understand. Yeah, go ahead.
Yes, in Vertex AI, in the tool part, I think there is. I can share the link.
Okay, thank you. I appreciate it.
Also, I can actually show what happens if you use a model which does not understand what's going on. I'll show that. Yeah. Do we have another question? Yes.
Hi. Yeah. What about set of functions? Like the user query is give me the average of all transaction, and functions we have is all these addition, subtraction, multiplication, and division, and it has to use all addition first and then division with the to make the average count. So can it do those two-step things, or it has to have one function only?
No, you can pass. You can. So there are two things. For exact this example, you might want to divide the word, kind of like, okay, uh, take that. Like, what does it mean by average? So if it is part of that, so I think that goes back to the previous question, that okay, what is supported when we say function calling? What are the already supported functions, and what we can kind of like build on top of that? So based on that, you might want to design how you want to do it. For example, we will see a demo where we extract uh, structured data or build structured data from non-structured data, also where we kind of like extract data from a web page in a structured manner, how we do with that. So we will go into that. But all of them, you will see we are using certain things to kind of like uh, I won't say sanitize, but kind of clean the data in a certain format.
Okay.
Okay. So going forward, for this specific use case, we have certain allowed and disallowed kind of like types. So here you will see what are the allowed types and what this actually understands. So if you look inside it, if we look what's happening inside, so you will see that these are the function declarations. So this is the multiply, description is this, and this is what it expects it to be, the types and the values. This is handled by the GLM tool, and this actually inside does like it declares and it does the multiplication. It actually understands what's happening there. So, oh, so we did not define this. Okay. So here when we run it, the calculator GMT tool, and we have this is like where you actually describe it. So this is our description multiply, and this is the description I think Aaron was talking about, that okay, this is the return of products of two numbers. And then these are the parameters is expecting that okay, this is my object, this is the schema, these are the numbers and what you want to get. Once it's done, this is the compatible format. So once we do that, we can do something like this, where we can just pass that, okay, this start chat and give me an answer of what is the multiplication of this. It goes inside. This is how it works. And then it executes it and you get the answer back. So once you have the response, you can just pass it on, and that's essentially what your response will be. Now, this is very simple, like calculator. What if we want to do something more? So let's go into something like, share this tab, extracting structured data. We do the same things. So this is our example task. We want to extract kind of entities from natural language stories, and this is a like story written by Gemini. This is one of the like example collabs I'm running. Okay, so this is our story. Once we have it, now we want to change certain things in that. So Gemini, by default, if you want to have it passed in JSON, it doesn't have a JSON parsing tool or JSON parsing mode available. You can prompt it to do that, but it probably can, probably cannot, but let's see. So right now we don't have it. We actually kind of try to prompt it, literally saying that, okay, describe it, like describe what we want, and kind of like prompt tune it that, okay, give me a response based on this, what I give you. So this is the whole prompt. All fields are required. This is literally prompt tuning, and we are asking that, okay, based on the story, here is the story, and give me kind of like a result like this. And now if we want to parse it, this is what we get. This is based on the previous this response. So if you see, we have people, name, description, place, name, description, place, name, description, place, something like that. Sometimes the end place, you see the end place is not there, something like that. Now, these are the different places and their descriptions. So we got all this, but just by prompting on it. It's pretty good, but it's not probably good enough. And let's check, like, can we depend on it? Now, this is relatively simple, mostly will work, but it will probably not work if you have a bigger number of relationships, more complex relationships, and if you want to have a JSON with more complex kind of schema. So let's try function calling on that. First, let us define what we want, that schema we want. So here we are using JLM. Just give me a second. My apologies. I'm in a room which was locked. Okay, so let's define the schema. What do we want? So let's look here what we had: name, description, start place, end place. So we define what it is. Name should be a string. So name, description, start place, end place. And these are our required fields. We ask it that, okay, this is what our schema will be for a person. And then let's define the people as array of this person object. So we have a person object. Now we define that as an array of this people, so that we can have all of them inside people. And then we do the same for places and things and relationships, what we had there. These are all just normal. We are just defining what we want. Now we are defining the whole function declaration of what we want to do, because we eventually want it to be added to a database. And that's why we are kind of extracting this as a JSON object. So we just define what has to be, what this object will hold, all the relationships. And now if we call the API, so what we do is that we go into, we just define what the model, and the tool is add to database. So this is literally what we had defined here. So we call it, and then let's see what are the results. So we define model and we called it with this tool, and then let's see the result when we pass our content. So we passed our story here, and we asked it add the people, things, and relationships from the story to the database. So people, place, things, and relationship, it will go back, it will look at the tool that, okay, these are available, and the database is what we passed as add to database. So it will literally try to see first inside these tools what's available. Now, once we do that, let's see what are the candidates. Okay, we can do it. And now we dump that. So here we have all the story, we have passed it, and all the descriptions and the names. And let's start looking at all the data. If you see here, you will see this is the place name, this is the name, and then you also have end place name, which was not available in the previous parsing. If we go inside, you will see this is a much more structured data. This has much better information, and it should technically be correct because we have defined exactly what to do, and it can build all of those based on what we had defined. Now, this is how you can handle structured data extraction from pure text. Now, what if we want to do something even more? So, what if we want to output a very specific data in array format? Now, though the last two, we could use MakerSuite API to do that. You can still do that here, but I wanted to also cover what you can do specifically using Vertex AI. So this is a function calling here. We are using Vertex AI to do that. So I'll just run it. I'll authenticate. Since I'm running in Colab, you have to authenticate it. If you are running it in Vertex AI notebook, you don't need this step. Once we have authenticated, we point it to the project. We have all the APIs enabled. For me, this is the project name, this is the location, and I run it. Now, if you have the previous Colab open, you will see something from the imports I'm doing from Vertex AI generative models. One of them is function declaration. Why does it matter? Why didn't we do it in the last time? Let's see what it enables us to do. So now I open my model, then let me go into my data. So I have a plethora of data and I can have a lot more of data, but let's just start with this financial data. And then we define a function call to get structured object back from that data. So this is a received data. So if you see some of the sprints people are doing and everything, you will see a lot of people are kind of like building applications that, okay, we can generate invoice text, or we can take a picture and generate invoice data. So you can use techniques like this to make it more interesting instead of just trying to get an image and get that. So this will be a fun objective to do, that trying to just pass a whole image to a model which can handle multimodality, and just tell it that, okay, can you give me all like what I have spent my money on or something like that. You can do a OCR, get all these, and then put it through something like that and do a function call. So we wanted to get a structured data back from the receipt. So this is what we defined. So extract financial data from receipt. What do we have? What do we expect the receipt to have? So movie, theater, date, daily, total admission, theater total admission, something like that. And then we pass it this, okay. Oh, sorry. This was not this. Okay. And then if you run it, we pass that and it's done. And then we get the response that I cannot fulfill this request. The required data does not contain request information. Now, if we want to define, actually, no, this should not happen. Wait. So it was still okay. So that's why. So now if you go through that, you will see we have the received data. So we have the daily totals. So admission, it's 205, daily total revenue, and the date, and the movie name and the theater. But we essentially get one data back. We want to have more. So instead of just defining this, to extract one data, we define it as an array. So here we define the record as type array so that it can extract more data. And now when we run it, this is what you get. So you have the receipts, daily total admission, one, you have multiple. So see, one by one, we have multiple data in here. Now, this is how you can extract array data from it. Going back to one of the previous questions we had, how do we know which model supports what, and does all models support everything? If you have noticed, when I was trying it, we had a different model defined. So I had this defined. And if you run it, oh no, this account doesn't have this available, but I'll show you for a different one what happens. So some of these are not available for all the models. So if you run it, it will show that that specific tool is not available for this model. Okay, before we go to our last demo, is there any other questions?
Is everybody able to follow so far?
I'm not doing the hands-on, but I will follow I will execute later. But maybe a question is that earlier with the previous notebook, when you had the message that it doesn't have enough information, that wasn't an error, right? It was for real, and it realized that it didn't hallucinate. That it okay.
Yeah, so that's why. So it didn't have enough information because it couldn't utilize the tool. So the error I'm getting right now is the error most people should get. But if you have access to the model and if you run it with a function it's not able to utilize, so it cannot extract any data, so it doesn't have any information to kind of give you answer to that.
Thank you.
Okay, so let's go to the...
I just have one question.
Yes.
So for the previous example, right, where you're extracting the entities and then having the output in the JSON format. So
Yeah.
let's say we didn't have a function calling mechanism in there, right?
Yeah.
So what would be the problems?
No problem, actually. It will literally try to extract it based on its like what your prompt is. So instead of a JSON format, you will get a like long text response based on... Actually, we can try it. Yeah, so you will get a like long text response based on that your question. It will give you not a structured data. It will just give you the whole text input.
Okay.
Then you can ask it via prompt that, okay, this text make me like give me in this specific format. That's what we tried in the first example. Remember that we defined the whole schema structure, but in the prompt itself. So we asked in the prompt that, okay, follow this, give me the answer in this format, and it tried to do that. But we'll see that that is always inferior or oftentimes even wrong for the examples if we want to do like if we define a function call for that.
Got it. Yeah.
I hope I have that example. Okay, let's go with that and then... Okay, I had another example which specifically goes into that question, but okay. So here we are trying to prompt a JSON structured JSON output without the function calling. So exactly, Rajesh, what kind of like so this is similar to like what would have happened if the function call was not there. So we are defining something. We have an animal name here and we have a prompt here. And inside the prompt, we literally ask that, so whatever it is, that, okay, do this and give us an output of 10 words of titles and 20 words of detailed description of the photo in a JSON format like this. So we are defining, we are defining a specific format for this. And what we ask here is that you are a professional photographer and you will publish a photo book of hummingbird here. What kind of photos and scenes will you choose to make the photo book attractive and fun that focuses on their facial features, habitat, families, and herds in different scene and seasons? So we're giving a lot of credit and asking it specifically for its output. Now the output is 10 words of titles and description. So it will be literally like this. And then we run it. So we're giving it a maximum output token, the temperature, and top P. So this is kind of the result we have. So close-up photos of hummingbird face, and then this is description. This is this. As you see, this is mostly pretty good. Now, if we want to use it using function call unstructured data. So if you want, so this is kind of like the helper function to parse the data. Now, here we are defining the function call. So this is the name, generate photograph content function declaration. So this is the name we're declaring, generate photograph content, assuming that's mostly what people will ask about it. And this is a detailed description, which will be very important because based on that, the LLM will decide to use this function or not. So you're a professional photographer, you'll publish a photo book. What kind of photos will you choose? Etc., etc., etc. If you see, this is very similar to this prompt we were giving. And then these are the parameters, like this is what the JSON schema we defined in that prompt. We are actually defining it here in proper schema. So object type array so that we can have multiple of it. And then we decided description, a list of photo titles, photo details, and title of the photo. And this is the template we want our output to be in. Once we have it, we register it as a tool. Without that, it doesn't know this is a tool. It won't know how to use it. And then we just ask it the simple question without all the other prompts. Generate about 10 options for a photo book about hummingbirds. Here we pass the tool this one. This will not work without registering it. So because we have registered now this as a tool, we can pass it here. And this is the output. So if you see the whole thing, this is exactly how we had defined the structure. So photos, inside photos, we have descriptions, title, description, everything. And this is a proper array. So if you want to use this workflow in your application, you probably have to ensure that the output exactly is the exact type you want it to be, the exact array, and there are no ambiguities. It looks like an array, but not array. These kind of errors you don't want to get, which is very possible with things like this. And if you see, this is not, it doesn't have the exact structure we wanted here. Once we have it, we can literally just write a normal Python function to see that, okay, can we just go through that and parse it, and it literally goes to a for loop and literally prints all of them. So hummingbird in flight, hummingbird home, hummingbird food, all of them exactly how we want. So that's how we can kind of like get a structured data response from calling a function. So yeah, if you want to play with any of these, so you can just go here. These two does not need you to use Vertex AI. These two requires you to use Vertex AI. None of them are a hard requirement. You can retrofit these two to use MakerSuite API if you want. And Gemini 1.0 in MakerSuite supports function calling. So you can actually just use it. You just have to define certain functions of your own. But in these examples, that's what we are doing. So you can just work with that. Coming back. So mostly what we had discussed in throughout this Google Notebooks collapse is we have certain allowed types which we can use for this function calling. These we define for the multiply. That's what we defined, and we ask tell it that the tool is multiply, and that's how you can call. Mostly function calling can be done in two modality. We have mostly looked at chat session, how you can do function calling through chat, and it can have history of that as well. So this is how the chat modality we have used. So we have the enable automatic function calling true. If you have it, it will automatically try to see if there is a function calling, it will try to use it. So this is the example we saw there. And if we want it to use the history, it can also use the history to collect all the previous calls and responses that took place. So you don't have to define specifically or define a memory to pass that object every time to that. So this is what we saw in one of the first collabs, that if you do at the content chat history, it will show you that how it came to that result, and you can actually use this in future references as well. So this is how the interaction actually looks like. You have text, which is your content, and you have the tools. These are the function declarations. If you have more than one function provided, function calling feature will automatically turn on, or you can actually do one and register that as a function as well. So the model may predict a function call based on user content. That's the may, is that your function call might not even get called. So that's the caveat. So a little bit careful about testing this. Then you get a response of the function. It gets model understands the response and adds it to the generic text, or ask it another function. Is there any question after this? Yes.
Quick question, Rabimba. So it could and could not call the function. So I get that. And then earlier you mentioned that we could kind of nudge it a little bit to call the function by doing extension grounding, right?
Yes.
How do you do that?
So the description where we describe the function, the better you describe, the better the function names are, it will try to automatically go for that. So if you see, to be very safe, most of these examples use exact. So when I was showing it, the examples and the prompts, so that I don't kind of mess it up here, they are exactly very similar to what we had in the function call. If you go too much different from what the like your description is, it might not call the function. So that's something you have to be very careful about.
So actually describing it in a certain way, that's what extension grounding means?
No, extension grounding is actually very different. So or the real extension grounding was before function calling. Vertex AI supported something called extensions that used to do something very similar. So there you had that concept of extension grounding, which was in that slide, but you can do the very similar things here by doing going for a very proper description.
So this is like kind of the poor man's way of doing extension calling, grounding.
Because extension was Vertex AI specific thing.
Got it. Thank you.
And I think we have another question.
I have just a few questions. First is, can there be multiple calls within a query, for example, identifying a color, and then the second function would produce the hexacode for the color or something like that? So can it fit multiple functions?
Yes, it can.
Then which model right now is the smartest? Like we have the 1.5 Pro, 1.0 Ultra, 1.0.
So I have access to 1.0, and that's most of the experiments I could play around with. Off topic, I have access to something else which I played around. It wasn't that good, so I would suggest 1.0. having said that, there was another question which can build up on your question, which I was kind of expecting somebody would ask is, yes, it can call multiple functions, but if the first answer doesn't come right, what happens then? So what happens
Well.
is that if you look the last one, so the model can call the first one, it gets result, but it's not exactly fitting that. It can call another function again. Or it can call the same function again. Now comes the most interesting part. Can you go in a loop?
Well, I remember at one of the Google AI events, the LLM actually was executing code.
Yes.
It's crazy. So maybe it can.
Yes, it can execute code. So that's code execution can be just another function, but essentially, so one thing. So I just wanted to bring it up for one question only. So yeah, what Alan was saying, open has parallel function request, but that opens up this whole that can open. I mean, people have experienced this. That opens up this whole can of worm that you can get into a function calling loop. And so you have to be a little bit careful about how you design the system so that you don't go into those scenarios, or have at least safeguards where it can just keep on going into a loop. Like when it calls a function, it doesn't get the result, but it thinks it has to call that same function again to get the result, and it doesn't. So you have to have safeguards in the code to not get into a infinite loop.
Last question, sorry. I find this super useful that you can plug the LLM into APIs, but then usually APIs can have many dozens of endpoints. But at the same time, oftentimes these APIs have nice Swagger documentation or something. Is this possible to like point the LLM to a Swagger and then it would discover the APIs itself, or I need to do that right now?
I have not played with it, so I won't be able to actually say what happens. But I would believe that you will probably have to do it. I don't think it can automatically do that. If anybody knows, I'll be very happy to get corrected. Yeah,
maybe I will write that.
Yeah, I just wanted to quickly mention the specification that gets passed to Gemini in the tools section of the request is identical to OpenAPI 3, which is Swagger. So if you have a Swagger specification, you can, well, let me rephrase that. It is a subset of the Swagger specification. So if you've got a Swagger specification from an API, in most cases, you can just feed that directly in and it should work.
That's awesome. I didn't know that. Thanks.
Yeah. So actually, I don't have that. So anyway, I'll share another collab after we are done, because I don't think we have much time, which will show you how you can call, literally you can do a curl call, or you can call a separate API outside. So in wild internet, you can call an API, get a response, and use that response directly in your code to get structured data out. I'll post that link. I'll also upload that in the GitHub and post that link here so that you can play with it. So that you can just play with that. Now, quickly going. So there are other examples. For example, this one, you can use Gemini to kind of call Wikipedia, get the list, and so this one calls Wikipedia, get certain informations out, change it, and work with that. So this is the SQL talk in app we saw in the beginning. And this is, instead of going here, let me show actually the code. Which of course had to shut down right now. Okay, it went away. Anyway, so the code is available in GitHub, so you can just clone it or you can just play with it. So you will see how we can communicate with a BigQuery dataset and how you can do something similar to that. So that utilizes function like this SQL query function, where we define the parameters and ask it to give us a result. So this is what it was based on a specific schema. These are the same things we talked. The function is calling structured data. I'm just skipping it because we are low in time. So if you want to learn more, you can go to aigoogle.dev, the Discord channel. This has a lot of information and a lot of other projects like this. But more specifically, what we talked today. So if these are the 3 links, you can go for a lot of these information. So the cloud, google.com, Vertex AI, generative AI docs, multimodal. The function calling has a lot of other examples similar to what we showed today. And you can play with them. Most of them you can run it in Vertex AI. But if you follow some of the like collabs you have here, you can use Maker Studio to kind of do the same exact things. The second link is Google's generative AI whole repository that has a lot of good data, lot of notebooks to play with in using function calling, but also using overall LLMs. And most of the things I showed today is available in this repository on the third link in my GitHub. With that,
Rabimba, actually, can you share those 3 links in the chat?
Yes, I'm in the last 1 minute.
Yes,
And
please.
now I'll be happy to take questions.
That 3 links, and then you had the link to the eSQL talk.
Yeah.
As well, and there was 1 link before that. Sorry. If you could, please.
Oh, I'll just paste them in the chat. Wait, just give me a moment.
Thank you.
Okay, this is here.
Awesome.
And
question.
Yeah, I'll share the slides as well. But I think we have covered these mostly in the notebooks. But let me.
Actually, if you share the slides, then I can take it out from the slide.
So I'll share the slide. So this is the app, and this is the source code. So this is the app. This is the source code. Yeah. We have a question, I guess.
Yes.
Yeah, we will circulate all the other slides and the recording by tomorrow morning.
Yeah, I have a question.
Yeah.
So you mentioned, Rabimba, that the function call can get into a loop. I was wondering what happens if it does. Like, how do you exit it? How do you get out of it?
Exactly. That's why I said you don't. Once it's in the loop, you probably won't get out of it with good information. So that's why I say that it's important to kind of design it with safeguards that after certain number of calls, after certain number of executions, it should not continue, or some safeguards. I will get back to you because I have not delved too much into specifically that if Gemini automatically has a safeguard, but OpenAI, I mean, if you use it for GPT, this doesn't, and people have gotten into that before. Especially as Alan said, GPT allows for parallel function calls, and it's kind of easy to get into that if it's not properly defined. So yeah.
Got it. Thank you.
Do you have any other questions?
We can stick around for another few minutes to take any questions if you all have any.
Before the SQL calling link, there was one other link, I think, which I missed.
Wait, let me check.
But if you can share.
Yeah, I'll share the slides, so that should be fine.
I just fear that this will roll off of my horizon, and then I can lose it. I tried your sorry if it's off topic, the Gemma app, and it was coming back with some error messages to me.
What kind? I mean, okay, so this depends on web GPU and Chrome. So you need Chrome or IE, like sorry, Edge.
Yes.
So if you have both of those, like any one of those, and if you have your web GPU enabled, it should work.
Or
But
maybe the web.
you can send me the error. I can see what's going on.
Okay. Yeah, it's I am on Linux, Chromium Beta,
but
and Android. Sorry, AMD GPU. So maybe the GPU is not good. Anyway, I will.
Yeah.
Unfortunately, AMD GPUs are not too widespread.
No, it should still work, but
Okay.
I guess the Linux might be the problem.
It says like init error.
Yeah, that is probably
cannot find adapter.
Yeah, so that means it couldn't find a web GPU adapter.
Okay, I will debug that.
Yeah, ideally, if you have an Android, new enough Android, it should even work in mobile Chrome.
Okay. All right, I will try that too.
Yeah.
And do you have a source code for that, by the way? That the Gemma.
Yes. I mean, the source code is very simple. If you just go to like this, if you just do an inspect element, you will see that's like a couple of lines of JavaScript code.
Okay.
The interesting part is the WASM file it's loading. So I convert that Gemma 2B is converted to a WASM file, WebAssembly, that is getting loaded by the MLC LLM. And we have that. So converting the widths to the MLC, like the WebAssembly format, was the other script. But I can share also those, like the whole WASM file. I can share, like that's in my website. So I can just share with them, and you just download it and ready-made use it for almost anywhere.
I thought that they have a precompiled WASM, but maybe I'm wrong.
Gemma?
Or maybe that's for, so you use actually MLC LLM here? So
yes,
not the TensorFlow.
It's not MediaPipe.
Right?
And also,
okay.
yeah, I built it like this one when the Gemma first released. So that time MediaPipe extensions were not available. Like they didn't release it that time.
All right, thanks. Nice.
Okay. Do we have any other questions?
I think that's it. Rabimba, thank you so much. I know this was a last minute request that came through. Rabimba, where are you based? Are you available to attend some of the GDG events, Build with AI events? You want to give a little bit of a...
Yeah. So I'm based out of Houston, and I'll be very happy to go to, if you have any events or workshops, I'll be very happy to travel there. So if you have something, get in touch with me. These are kind of my contacts, or I think if you get in touch with the team, that also works.
And you have a sessionized profile put together yet?
What? I couldn't hear you.
A sessionized profile.
Oh, yes, I do. Let me just share that.
And I'll share with the community as well. But yeah. For those who are tuning in, thank you so much. Give us some feedback if you have some time. Welcome to add it on our polls, or just send me a DM or an email. We got 2 more sessions coming, one tomorrow and another day after. Tomorrow is going to be David Cardoso, and Friday we're going to talk about safety with Alan. I am trying to get some cloud credits for you all, so at least even if you don't use it, we can test it out, see how things go. Then we can collect some feedback and share with the cloud folks. So when you run your event, you'll be ready you're much more confident with ironing out all these bugs. So that being said, I want to say have a great night, great evening, and see you all tomorrow.
See you. Thanks for having me.
Thank you.